I've been driving an electric vehicle as my daily driver since 2009. That's nearly 17 years of driving an electric vehicle every day. And over the course of that time, I've owned 12 different electric vehicles and driven about 500,000 electric miles. And I've talked to a lot of people over the years about what it's like to live with an electric car. But one of the questions I seem to always get is, Tom, how long does it really take to charge an electric vehicle? Now, the quick, down and dirty answer might be, well, if you can charge at home, it'll be fully charged by the morning as long as you can charge from a 240 volt level 2 charging source, which most people can install in their homes. And when you're on the road, if you plug in at a low state of charge and charge up to about 80%, it's going to take around a half an hour. And for many people, that quick answer is enough. But I know there's a lot of people out there that want more details. And this is state of charge. So that's what we're going to do here today. We're going to do a deep dive into exactly how long does it take to charge an electric vehicle from the different types of charging sources. Let's get into it. All right, so I started off by saying that in most cases, most electric vehicles can fully recharge overnight, provided you could plug into a level 2 charger at home and you have the ability to charge at home. And when you're on a road trip, you could figure if you plug in at somewhere around 10 or 15%, you can get up to 80% in about a half an hour. Now, there's some EVs that'll do it faster, and there's some EVs that'll take a little bit longer. That's because different EVs have different charging capabilities, and also different charging stations can deliver different amounts of power. We're going to go over all of that here today. But before we get into it, let's first take a look at some of the general electric vehicle charging abbreviations and terms that I'll be using throughout this video. Okay, first up, I'm going to be referring to electric vehicle charging equipment as chargers. But actually, in reality, the proper term is EVSE, which stands for Electric Vehicle Supply Equipment. The reason why they're not technically chargers is because what they do is really just provide electricity safely to your electric vehicle. The actual charger is built into the electric vehicle, and that's called the onboard charger. The onboard charger is a power electronics device that's built into every electric vehicle. What it does is it converts the AC electric provided by the EVSE, or what we typically call chargers, from a source such as your residential home to DC electric, which is how the electricity is stored in an electric vehicle's battery pack. However, I'm going to refer to the charging equipment as chargers from here out because that's what most people understand them as. And quite honestly, I don't think a lot of people are going to be saying, oh, I need to go buy an EVSE. They're going to say, I need to buy an electric car charger. So we're going to call them chargers, but I just want to make sure everybody understands what the proper term is. Next up, let's talk about the 3 different levels of charging. Level 1 charging is when you're charging from a 120 volt source. Now, some people call this 110. You can call it 110, 120. It's the same thing. Here in North America, our regular household electric is based on 120 volts. So if you're charging from a level 1 charging source, you're plugged into a regular household outlet. You can do that, but it'll take very long to charge your electric vehicle because 120 volt sources don't supply a lot of electric. We'll talk about that a little later. Now, level 2 charging is when you charge from a 240 volt source. Now, some people might be concerned and say, well, if my house has 120 volts, I can't charge from 240 volts at home. That's not true. What your electrician does is he just pairs 2 circuits, basically doubling the voltage. He puts them together. So then you have 240 volts. You already have 240 volt circuits in your home. At least most people do. Common 240 volt appliances might be an electric range or a electric clothes dryer. So it would be very similar to those appliances when you install a circuit for your EV charging. And then finally, we're going to talk about level 3 charging. Now, level 3 charging isn't actually the proper term. The proper term is DC fast charging, but most people refer to it as level 3 charging. Okay, next let's talk about volts. We're going to talk about volts here. Volts are a measurement of the amount of force of the electricity. It's kind of like the speed of the flow of the electrons through the electric circuit. Next up, amps. Amps are the volume of the electrons in the current. Now we're going to talk a lot about amps here today because EV chargers, as well as the onboard chargers in the EVs, are typically listed by the number of amps they can deliver or accept, respectively. Next up, kilowatt. Now a kilowatt refers to how much power the charger can deliver, as well as how much power the onboard charger in your EV can accept. Now I know I just said that that's typically listed as amps. Well, there's two ways that you can talk about the power that the charger outputs as well as the onboard charger can take in amps or in kilowatts. The way you get to kilowatts is you multiply the amps by the amount of volts. So for instance, if you had a 240 volt circuit and a 40 amp charger, you'd multiply 240 by 40, which you'd get 9,600. That's 9,600 watts or 9.6 kilowatt. So someone would refer to that charger as either a 40 amp charger or a 9.6 kilowatt charger. The same goes for the onboard charger. They would refer to it as either a 40 amp onboard charger or the charger can accept 9.6 kilowatt. Next up, kilowatt hour. Think of kilowatt hour as the electric equivalent to gallons of gasoline. A gas car has a fuel tank that can store a certain number of gallons of gas, and an EV has a battery that can store a certain number of kilowatt hour. With combustion cars, we measure their efficiency in miles per gallon, and with EVs, we use miles per kilowatt hour. Pretty simple. Next up, dedicated circuit. A dedicated electrical circuit means that there are no other outlets or electrical devices on that circuit. EV charging equipment requires a dedicated circuit, so only the charger is being used for that circuit. It cannot be shared. Okay, so I mentioned that there's 3 levels of charging. Level 1 charging, level 2 charging, and DC fast charging, which is sometimes referred to as level 3 charging. Level 1 charging and level 2 charging uses AC electric, which is alternating current. And level 1 charging specifically is when you're going to charge off of a regular 120 volt household outlet. This is a level 1 charger. A few years ago, most electric vehicles came standard with a level 1 charger. And this allowed you to plug into a regular household outlet and charge your electric vehicle, albeit very slowly. That's because 120 volt electric doesn't provide a lot of power and it takes very long to charge an electric vehicle. Sometimes these are just called convenience chargers because it's not something that most people would use every day. But if you just happen to need to add a few extra miles and maybe you're away from home, you could plug into a regular outlet and add some miles to your EV. How many miles? Okay, well, most electric vehicles will add between 3 miles of range and 5 miles of range per hour of charging with a 120 volt level 1 charger. So as you can see, that's not a lot of power. But if you were to plug in overnight and let's say, for 10 hours the vehicle was plugged in, you could add between 30 and 50 miles of range to your EV, depending on how efficient the electric vehicle is. I'm giving this wide spread of miles here today when I talk about how quickly electric vehicles charge, because different electric vehicles are different efficiency. A big truck that's heavy electric vehicle like my Ford F-150 Lightning might only average around 2 miles per kilowatt hour, whereas a smaller, very efficient sedan, take for instance a Tesla Model 3, can average more than 4 miles per kilowatt hour, double the fuel economy. So I know we say fuel economy, but there's no other term really that works for that except consumption rate we talk about with electric vehicles. So, all of the charging times I give here today's video, there's going to be a wide spread between this and this because it really depends on how efficient your electric vehicle is. But for level 1 charging, you're looking at 3 to 5 miles of range per hour on average, which some people live with, believe it or not. There's some people that have an electric vehicle and they plug it in every day when they come home. They only drive 30 or 40 miles a day. So for them, they say, look, I can use this simple 120 volt charger. It gets me charged up every night. And on the rare occasions that it doesn't, or if I need to go farther, I find a public DC fast charger and charge up that way. So that's level 1 charging. But most people that own an electric vehicle and have the ability to charge at home are going to opt to charge on level 2, which is 240 volt AC charging. And unlike level 1 charging, different electric vehicles can accept a different amount of power. It depends on their onboard charger and how much power it can accept. There are some onboard chargers that are limited to 32 amps, some that are 40 amps, some 48 amps, and then there's even some that are 80 amp. And that really dictates how much power the electric vehicle can take in. Even if you were to buy an electric vehicle charger, or EVSE, that can deliver 80 amps, if your onboard charger is limited to 40 amps, that's all it will accept. And you don't have to worry about buying a charger that's, say, too powerful, because the vehicle is always going to call for the amount of power it can accept. So an 80 amp charger or a 48 amp charger won't harm a vehicle that has a 32 amp onboard charger. You can always put a more powerful AC charger in your garage and maybe future-proof in case you get an electric vehicle down the road that has a higher powered onboard charger, but it won't harm the onboard charger that you have in your electric vehicle now. That's a question that I get quite frequently. Most electric vehicles today come standard with a 48 amp onboard charger, which is 11.5 kilowatt of power that it can take in. But as I just mentioned, you can buy a more powerful charger, or you could even buy a charger that delivers less power, say 40 amps, which can deliver 9.6 kilowatts, even if your electric vehicle has a 48 amp onboard charger, because there's a communication process between the electric vehicle and the charger. And basically, when you connect, the car asks the charger, how much power do you have available? And the charger responds, well, I have 48 amps. And then the car says, well, I can only take 40 amps, so give me 40 amps. It won't call for more than it can accept. And there's, as I mentioned, a lot of different power levels that are available for charging equipment. So what we're going to do now is take a look at the chart that I prepared that explains how many miles of range you can expect to add to your electric vehicle depending on the amount of power it's taking in, which is dependent on how much power your onboard charger can accept and the charging equipment that you're charging on can deliver. So let's take a look at that chart now. Okay, now let's take a look at your EV charging circuits and approximate miles of range per hour added. Now in the first column there, you'll see your circuit breaker. This is the power that your circuit breaker needs to be able to provide. If we take a look at the first line, it's a 100 amp circuit breaker. Now the maximum output that can put out is 80 amps because when you install electric vehicle charging equipment, it's considered a continuous load, and the most power that you can continuously draw is 80% of what the circuit's maximum rating is. So if you have a 100 amp circuit, you can deliver 80 amps continuously. And if you do, the electric vehicle can accept up to 19.2 kilowatt. Now we arrive at that number by multiplying the amps versus the volts. 80, the amps, times 240, the volts, is 19,200. That's 19,200 watts. A kilowatt is 1,000 watts, so it's 19.2 kilowatt. If you charge at that speed, you can return somewhere between 35 and 75 miles of range per hour to an electric vehicle. I know that's a wide spread, but as we talked about, it's because some electric vehicles are much more efficient than others. Now, if you look at overnight charging, and this is where it's important here because most people will plug in and have their electric vehicle charging overnight. I use 10 hours as the average. For some people, their electric vehicle is home even longer. But as you can see, if you were able to charge from an 80 amp source, you'd replenish somewhere between 350 and up to 750 miles of electric driving range. Now, most electric vehicles can't deliver this kind of driving range. So basically what I'm saying is here is no matter when you plugged in, your EV would be fully charged. Now, if you take a look at the approximate amount of kilowatt hour that would be added overnight, it's 175. You'd have to have a massive 200 kilowatt hour battery pack not to be able to completely refill it overnight if you're charging from an 80 amp source and you rolled into your garage completely empty. Now, I'm not going to go over all of these numbers here, but let's take a look at some of the common EV charging circuits, like a 40 amp circuit. Now, 40 amp circuit, the power delivery is 9.6 kilowatt. And what you would do there is add somewhere between 18 and 38 miles of range per hour of charging. The 18 would be something if you had a Ford F-150 Lightning or a Chevy Silverado EV, some of the big heavy EVs that aren't very efficient. Then once you get up to the Hyundai Ioniq 6s or Tesla Model 3s that are very efficient, you'd get close to 40 miles of range added per hour. And overnight, as you can see there, somewhere between 175 and 375 miles of range. And you'd add 85 kilowatt hours to the battery pack, which is larger than what most battery packs are with overnight charging. Now, let's say you really don't have a lot of spare capacity in your panel, and you can only add a 30 amp circuit for electric vehicle charging. You'd have to limit your charging to 24 amps, and the power delivery would be 5.7 kilowatt. And you can see here you'd get somewhere between 10 and 22 miles of range added per hour, and overnight you'd add 100 to 220 miles of range, depending on how efficient your EV is. And you'd add up to 50 kilowatt hour overnight. And you have to understand, you're not rolling into your garage every day with an empty battery pack, or at least most people aren't. You only have to replenish what you use that day. And the average person drives 40 or 50 miles per day. So in almost every instance on this chart here, you could see with overnight charging, even charging at a very low rate, you'll fully replenish what you used the day before on an average day. Sure, there's going to be some days that you may not completely top off. And if you really needed to go on a long distance trip the next day and you weren't fully charged, you could stop at a public DC fast charger and top off for the trip. So basically what I wanted to show with this chart here is even with lower powered home charging, it'll be adequate for most owners with most electric vehicles. State of Charge is powered by Qmerit, North America's premier installer of electric vehicle charging equipment. After I've helped you decide which charger to buy, follow the link in the description of my videos and have Qmerit install it. And if you do follow that link, Qmerit will waive the $150 installation deposit. But this is an exclusive offer for State of Charge followers. So in order to get that offer, you must follow the link in the description of my videos. So as you can see, charging at home from a level 2 AC source overnight, even if you don't have a high-powered level 2 charger, you can almost always replenish the amount of miles you drove the day before. Now, it's good policy to plug in every night, but many people wait a couple of days and will plug in once maybe the battery gets down to 30% or something like that. I always recommend just plugging in every night. It's not bad for the battery. It's not any worse than if you waited till you were 20 or 30% and then recharged. We like to say a charged battery is a happy battery. So don't be afraid to plug in your electric vehicle every night, and that way you know every morning you're ready to go. And one of the things I want to talk about with AC charging is whatever level of power you're charging at. A 40 amp charger, that's 9.6 kilowatt, or a 48 amp charger, that's 11.5 kilowatt. When you plug in your vehicle, it's going to very quickly go up to that maximum charging rate, and it holds it steadily throughout the entire charging session until you're about 98 or 99% charged. And then the charging rate slows down because the battery management system gradually tops off all the battery cells to make sure that they're all charged to the right amount. It's not that way with DC fast charging, which we're going to get into next. But before we jump into DC fast charging, I just want to show you this graphic so everybody completely understands how AC charging works. Okay, so with AC charging, you've got your electric vehicle supply equipment, the EVSE, that we typically call a charger, and it will be plugged in or hardwired to a 240 volt AC source. The power from the charger goes through the cable to the connector into your electric vehicle and into your onboard charger. That's what converts the AC to DC electric, because the electricity needs to be stored as DC in the battery. But after it leaves the onboard charger, it goes through your battery management system, we call it the BMS, and then into the battery pack. Now with DC charging, most commonly called DC fast charging or even level 3 charging, even though that isn't the proper term, some people will naturally call it that because there's level 1, which is 120 volt, level 2, 240 volt, and then they figure, well, level 3 must be the next step up of charging, but the proper term is DC fast charging. With DC fast charging, the vehicle does not charge at a constant rate like we see with AC charging. In fact, it's anything but constant. And unfortunately, all electric vehicles have different charging curves, we call them. Most all electric vehicles, when you first plug in, will take a lot of power, the maximum charging rate that it'll accept, but it does it for a short period of time, and then it slows down the charging rate as the state of charge increases. And that's because the battery cells cannot sustain or cannot accept a high amount of power once they're at a higher state of charge. As the state of charge increases, they can accept less power. So a typical charging curve will be, you'll plug in, you'll get a lot of power, and then the charging rate will gradually slow down till it gets to about 80%. And then in most electric vehicles, it slows down dramatically. And that's why most people will recommend, when you go to a DC fast charger, don't charge beyond 80% because you're typically there waiting for the car. It's not like home charging where you're sleeping. You're in the car or you're getting coffee right next to the charger waiting for the car to charge. And once it gets to 80, 85%, it's going to start charging much slower than it did for the rest of the charging curve. In fact, many electric vehicles will take longer to charge from 80% to 100% than they did from 0 to 80%. So you can get 80% of the battery faster than you can get the final 20% of the battery. So when you're on a road trip or when you're at a DC fast charger, unless you absolutely need that extra range, unplug it around 80%. It's just not worth your time sitting around and waiting. So before we jump into how long it takes to charge a DC fast charger, let's take a look at a graphic on exactly how DC fast charging works. Okay, so you can see we have a nice DC fast charger graphic, and the power comes out of that, goes through the connector and into the electric vehicle. But now you notice it doesn't go into the onboard charger. It doesn't need to because it's already DC electric. Remember, the onboard charger converts the AC electric to DC so it could be stored in the battery. And this is why you can charge so much faster at a DC fast charger. The onboard charger is the bottleneck. That restricts the amount of power that can go through the vehicle. Now you don't have to go through the onboard charger. So you're going from the DC fast charger directly into the battery management system and into your battery pack. So now the electric vehicle can accept a lot more power and charge a lot faster because it's charging from a DC source already. It doesn't need to convert AC to DC electric. Okay, so not having to go through the onboard charger means the battery can accept a lot more power. But the thing is, and this is what makes explaining how long it takes to charge an electric vehicle so difficult, all electric vehicles accept varying amounts of power. And all DC fast chargers deliver different amounts of power. There's no easy way to explain this. Every electric vehicle pretty much will charge at a different rate. And it gets even more difficult because they'll charge at different rates depending on the battery temperature. If the battery's nice and warm, they'll take in their maximum power. But if you cold soak your electric vehicle out in 10-degree Fahrenheit weather all night and then you plug into a DC fast charger, it won't charge half as fast as it would have if the battery was warm. Now there's things you could do to make the vehicle charge faster when it's really cold. A lot of electric vehicles now have battery conditioning where you could turn it on and it'll warm up the battery as you're on the way to the DC fast charger. And some EVs do it automatically. If you set the DC fast charger as your destination, the car knows you're going to a DC fast charger and it immediately turns on battery warming. So by the time you get there, it can accept the maximum power. But again, the power isn't linear. You take a lot of power in it first and then it slows down. So let's take a quick look at a couple of graphics that I have that explain the charging curve of that particular electric vehicle and how the charging speed changes throughout the charging session. First up, let's take a look at the charging curve for my 2024 Chevrolet Equinox EV. I recorded this session on an EVgo 350 kilowatt DC fast charger, but as you can see from the charging power on the left of the graph, the vehicle didn't accept anywhere near 350 kilowatts, even though the station could deliver it. And that's because the Equinox is limited to accepting only about 150 kilowatt, and it only does it at the very beginning of the charging curve. As you can see here, for the first 10 minutes of charging, when I plugged in at 0% state of charge, the average power the vehicle took in was 150 kilowatt for the first 10 minutes. But then let's take a look at 20 minutes of charging. Over the course of 20 minutes of charging, the vehicle averaged only 110 kilowatt of power. That's because, as you can see here, after about 8 minutes of charging, the charging power dramatically decreases for the rest of the charging curve. Now let's take a look at my Ford F-150 Lightning's charging curve. On this curve, I charged from 10% to 80%. It wasn't a complete 0 to 100% charge recording. And if you take a look at the first 10 minutes of charging, it averaged 172 kilowatt of power. But then when you look at 30 minutes of charging, the average amount of power we took in was 147 kilowatt. And lastly, let's take a quick look at what I believe is the best fast charging electric vehicle that's available here in the US, and that's the Porsche Taycan. Take a look at that charging curve. It's really flat up front and it's 300 kilowatt. In fact, the first 10 minutes of charging averaged 300 kilowatt of power. But then when we take a look at 20 minutes of charging, the vehicle averaged 255 kilowatts, still outstanding, but lower nonetheless because, as you can see here, the charging rate eventually begins to lower as the state of charge increases. So as you can see with DC fast charging, there's a lot of variables. So there's no easy way to explain how fast an electric vehicle charges on a DC fast charger. They all charge differently, and they all charge differently at different types of charging stations. Now, one of the factors that allows electric vehicles to charge faster on a DC fast charger is the battery pack's voltage. When electric vehicles first came out, almost all the electric vehicles had what's considered a 400 volt battery system. However, a few years into this latest electric vehicle revolution, automakers started coming out with higher voltage battery packs. Porsche, for instance, is one of the companies that uses an 800 volt battery system. And having a higher voltage battery system allows the vehicle to charge at much higher rates without needing to take in more amperage, because the amperage is typically what limits the DC fast charging equipment. So if you can double the voltage and still deliver the same amount of amps, you're basically doubling what the charging rate's going to be. So electric vehicles that have higher voltage battery packs typically charge much faster than the vehicles that have the lower voltage battery packs, as you can see there with the Porsche Taycan. Lucid electric vehicles also have a higher voltage battery packs. Their battery packs are actually a little bit over 900 volts. They also charge incredibly fast. So as I mentioned, it's different for different electric vehicles. But now let's take a look at a chart that I made that'll show you about how many miles of range you can add depending on how long you charge and what the average amount of power your electric vehicle takes in. Of course, there's a lot of numbers on this chart, and you'd have to figure out exactly the amount of power your electric vehicle can accept and for how long you're going to charge to find this chart useful. But it is useful. Once you get the hang of it, you'll know pretty much about how many miles your electric vehicle can add depending on how long you stay at a DC fast charger. Okay, so I warned you, there's a lot of numbers here. And if you look all the way to the left, the average power in kilowatts, that's how much power your electric vehicle's taking in over the specific time period that you're charging. I started it way down at 50 kilowatt. Very few electric vehicles today are only going to average around 50 kilowatt. Most are going to average somewhere between 100 and 200 kilowatt, as long as you can plug in at a low state of charge. Again, if you're charging at a very high state of charge, you might even be below 50 kilowatt, but I don't recommend people charge at a very high state of charge at a DC fast charger. So let's start at the top of the chart. First of all, there aren't many DC fast chargers in America that can deliver 400 kilowatt. There are new ones that are getting installed now that can. The Iona network, for instance, has all chargers that can deliver 400 kilowatt. So there are some 400 kilowatt DC fast chargers out there and a couple electric vehicles that can actually accept 400 kilowatt. So let's say you had a Lucid Gravity and you were at a 400 kilowatt DC fast charger and you only wanted to stop for 10 minutes, you would get somewhere between 120 and 250 miles. Now that's a wide spread. Why is that? Well, it goes back to the beginning when I explained that different electric vehicles have different consumption rates, different efficiency. If you were driving an electric vehicle that isn't very efficient, you might only get around 120 miles. But if you were in one that was a very efficient EV, you can get up to 250 miles. So these numbers here are just rough estimates that cover a spread from the least efficient electric vehicle to the most efficient electric vehicle. But pretty much every electric vehicle available will find itself somewhere within that spread, depending on the power level and the amount of time charging. For instance, I'm going to look up the Porsche Taycan here. If you remember, after 10 minutes of charging, the vehicle averaged 300 kilowatt of power taking in. So if you take a look here, 300 kilowatt, you go over to the 10-minute section, between 85 and 180 miles added. Now the Taycan isn't a tremendously efficient vehicle because it's a high-powered sports car. So in 10 minutes, it probably added somewhere around 150 miles, which was within this spread. After 20 minutes of charging, the average power was 255 kilowatts. And the vehicle had added somewhere around 270 miles, which again falls within the spread that I have published. Okay, well, I know that chart had a lot of numbers on it and it looks a little intimidating, but the fact is DC fast charging is very hard to explain, as I mentioned, because every electric vehicle charges at different rates, the charging equipment puts out different power, and then you have the fact, throw in that temperature can dramatically change how fast your EV is going to charge at a DC fast charger. It'll also affect AC charging, but not quite as much. What you might find if your battery is really cold, when you plug it in, it won't charge at the full rate for a little while till it warms up a little bit, and then it'll charge at the full rate. But you don't notice it as much with AC charging because you're typically charging for a very long time with AC charging already. Whereas with DC fast charging, if instead of needing 20 minutes, you need 35 minutes, that's a big difference. With AC charging, it might add a little bit extra time, but you notice it a lot with DC fast. And people always ask me, well, why do electric vehicles charge at different rates? Why don't the manufacturers just, make them all charge the same rate? Well, it's because there's different battery chemistries, different battery cells, and the manufacturers themselves have different strategy. Some manufacturers are willing to, let's say, stress the battery cells a little bit more to get higher charging rates, and other companies are more conservative and they're concerned that if they stress the batteries too much for too long of a period of time, it might shorten their life. The data that we're seeing now from DC fast charging over long term is very encouraging, and it doesn't appear that having high DC fast charge rates is really shortening battery life very much at all. And that's encouraging. People were concerned about that when electric vehicles first started coming out. You heard a lot of people saying, don't DC fast charge a lot, you're going to kill your battery. It's really not the case. And it's really basically because the cells are being designed to accept that power, number one. And number two, the vehicles have these complicated thermal management systems, these very sophisticated thermal management systems that are controlled by the BMS, the battery management system. And what that does is it controls the temperature of the battery pack. And when the battery pack gets too warm, it slows down charging. So that's really the enemy of your battery's long-term life, is if the cells get too hot for too long, that's what harms them. So while you're DC fast charging, if it's at a very high rate and it's in the middle of the summer and it's super hot out and the pack starts getting a little too warm, the vehicle will slow the charging rate down so that things can kind of cool off and you're not stressing the cells too much. All right, well, I hope that this kind of helped you figure out how long electric vehicles take to charge. I know the AC portion is a lot easier to digest than the DC portion, but the one thing I will say about DC fast charging, most electric vehicle manufacturers now will give you two numbers with regards to DC fast charging: the peak charging rate, and they'll also give you an approximate time to charge from, let's say, 10% to 80%. Some manufacturers give you that number from 15% to 80%. But be careful of falling in love with the peak charging rate, because some electric vehicles can accept a lot of power, but only for like a minute or two. And then it starts that slope down. So an electric vehicle that gets advertised as having a 200 kilowatt fast charging rate might actually charge slower than another electric vehicle where the manufacturer advertises 150 kilowatt DC fast charging rate, because that vehicle holds the power longer, like the Porsche Taycan did. If you remember that charging curve, it holds the maximum charging rate straight across, as opposed to my Chevy Equinox, where you saw it took power, but only for a few minutes, and then it dipped down tremendously. So the peak charging rate number alone doesn't tell the story. The average charging power over time is really what you need. And unfortunately, no auto manufacturer will give you that number. You've got to figure it out yourself when you're charging. And if you're really into trying to figure out how this charging works and everything, you can figure it out. I've given you kind of the idea of how you look at it. Look at that 10-minute time frame, that 20-minute time frame, see how many kilowatt hour the charger dispensed, and then you could figure out what your average charging rate is over a certain period of time. And then you'll know about how many miles you can expect to add with your electric vehicle, depending on its consumption rate for that specific period of time that you're charging. All right, well, that's all I have here today. I hope this helped you out. If you have electric vehicle charging questions, you could ask them here. You could also ask them on my website, evchargingstations.com. We try to respond to as many of the comments and questions that we get through the website. And if this is your first time here at State of Charge, please hit that subscribe button and ring the notification bell so you don't miss any upcoming electric vehicle news and reviews. And as always, thanks for watching.